What's on the other side of a black hole? Ever wondered what lies on the other side of a black hole? The mysteries and theories surrounding black holes have fascinated scientists and space enthusiasts alike for decades. In this episode of InfoBurst, we'll explore the tantalizing possibilities of what could await if you somehow manage to survive the journey through one of these cosmic behemoths. As you approach a black hole, the journey itself would be a spectacle of physics. Black holes are formed when massive stars collapse under their own gravity, creating a point of infinite density known as a singularity, surrounded by an event horizon. The event horizon is the boundary beyond which nothing, not even light, can escape the black hole's gravitational pull. Crossing this threshold means entering a realm where the laws of physics as we know them begin to break down. As you plunge into the event horizon, the point of no return, you would experience phenomena beyond human comprehension. The gravitational pull is so intense that even light cannot escape its grasp. This region, known as the event horizon, marks the boundary where the escape velocity exceeds the speed of light. Once you cross this threshold, you are inexorably drawn towards the singularity, the infinitely dense core of the black hole. Inside the event horizon, space and time become distorted. The concept of time, as we perceive it, would change dramatically. Due to the extreme warping of space-time, you would witness the universe around you speed up, observing the entire future history of the universe in a matter of moments. This effect is due to the intense gravitational time dilation near the event horizon, where time itself slows down relative to an outside observer. One of the most intriguing theories about what lies beyond a black hole is the possibility of wormholes. Wormholes, theoretical passages through space-time, could potentially connect distant parts of the universe, or even different universes altogether. If such structures exist within black holes, traveling through one could theoretically transport you to a completely different region of space, or an alternate universe. However, the stability of wormholes and the survival of anything passing through them remain speculative and largely theoretical. Another hypothesis is that black holes could lead to white holes, the theoretical opposites of black holes, where matter and energy are expelled rather than consumed. While this idea is fascinating, it remains purely speculative with no empirical evidence to support it. The singularity is where conventional physics breaks down. The laws of space and time as we understand them cease to apply. The immense gravitational forces would stretch your body into thin strands of atoms, a process known as spaghettification. Every molecule of your being would be stretched to its breaking point, ultimately being crushed at the singularity. But what if this isn't the end? Some theories propose that black holes could be gateways to other parts of our universe, or even entirely different universes. This idea stems from the concept of wormholes, theoretical passages through space-time that could connect distant regions of the cosmos. The notion of wormholes was first proposed by Albert Einstein and Einstein-Rosen in 1935, suggesting that a black hole could link to a white hole, a hypothetical region that expels matter and light. While the existence of wormholes remains purely theoretical, physicist Kip Thorne, a leading expert on the subject, has raised intriguing discussions about their potential. Thorne's work, especially his contributions to the movie Interstellar, popularized the idea that wormholes could provide shortcuts through space-time. However, Thorne himself admits that there is no firm evidence supporting the existence of wormholes, and journeys through these theoretical tunnels remain within the realm of science fiction. Despite the lack of empirical evidence, the concept of black holes as portals to other universes continues to capture the imagination of scientists and enthusiasts alike. In a 2014 study, physicists Carlo Rovelli and Hallam Haggard suggested that black holes might not lead to singularities, but instead could transition into white holes. This process, known as a quantum bounce, could theoretically allow information to escape from a black hole, shedding light on one of the most puzzling paradoxes in physics. Stephen Hawking, one of the most renowned cosmologists, explored the possibility that black holes emit radiation, now known as Hawking radiation. This radiation results from quantum fluctuations near the event horizon, causing the black hole to lose energy and eventually evaporate. Hawking's theory suggested that black holes do not last forever and could eventually disappear, leaving behind remnants of the information they absorbed. However, this idea led to the infamous black hole information paradox. According to quantum theory, information cannot be destroyed. But if black holes evaporate and disappear, what happens to the information they swallowed? This paradox has puzzled scientists for decades, and various theories have been proposed to resolve it. Some researchers, like Jorge Pullen and Rodolfo Gambini, have applied loop quantum gravity to suggest that black holes might not form singularities, but instead lead to other regions of the universe. The AMP's firewall hypothesis, proposed by Ahmed Almeri, Donald Meroff, Joseph Polchinski, and James Sully, presents another intriguing perspective. Their calculations suggest that the event horizon of a black hole could turn into a wall of fire, incinerating anything that comes into contact. This theory challenges Einstein's general theory of relativity, which states that objects in free fall should not feel extreme effects when crossing the event horizon. Stephen Hawking revisited his ideas in 2014, proposing that black holes might not have event horizons, but rather apparent horizons. These apparent horizons would temporarily retain matter and energy before releasing them later, aligning with quantum theory's principle that information cannot be destroyed. Hawking's rethinking suggests that black holes could eventually allow matter and energy to escape, but not in their original form, making it impossible to determine what went in by looking at what comes out. Despite these fascinating theories, the reality remains that we cannot observe what happens inside a black hole. The immense gravity prevents any light or information from escaping, making it impossible to take photographs or gather direct evidence. The study of black holes continues to be a theoretical endeavor, with scientists relying on mathematical models and indirect observations to unravel their mysteries. As we continue to explore the cosmos, black holes remain one of the most enigmatic and captivating phenomena. They challenge our understanding of physics and push the boundaries of what we know about the universe. Whether black holes lead to other parts of our universe, different universes, or simply to the end of time, they will continue to intrigue and inspire future generations of scientists and space enthusiasts. Thank you for joining us on this journey through the mysteries of black holes. Be sure to subscribe to InfoBurst for more fascinating explorations of the universe and beyond.